Assalamualaikum warahmatullahi taala wabarakatuh and salam sejahtera to all my students. Okay, I hope for today's lecture you are well prepared with your revision for chapter 1, which is migration rate of solute, because we are doing a tutorial for this today's lecture. So make sure you have a calculator with you, a pen or pencil, and also eraser, and also a paper. Okay, because I want you to write it back on your own writing so that you can easily understand what I explain with this slide. Because if you're just watching my slide, I don't think that you will do it well when we have our first test. Okay, so based on this tutorial, I will give you an assignment 1, which is covered about the calculation on migration rates and also the the questions about the mechanism in chromatography that we have covered before. So let's look at the exercise. Exercise 1. Okay, a chromatography analysis for the chlorinated pesticides give a peak with a retention time of 8.68 minutes with a baseline width of 0.29 minutes and 2 meter long. Determine the number of theoretical plate and the height of a theoretical plate. So the marks allocated for this question is 4 marks. Okay, before we proceed with the solution, you need to carefully read the question. What is the question 1 actually? So they want you to calculate the number of n and also the height, which is h. So look at the red color. This is the information that given, which is RT and W and also L value, right, in the formula given here. Okay, so you must use this formula to calculate the n value. Alright, so you need to use 16 bracket TR over W bracket square. Okay, we rarely use 5.5. Okay, we rarely use this equation, and mostly we use 16 bracket TR over W bracket square. Okay, so just ignore this equation. Okay, only use this equation. So you just insert the retention factor value 8.68 divided by W given here 0.29, and the value you will get is 14333.8 plates. Right? So the next question is to calculate the height, which is given by the formula n equal to L over h. So basically, the theoretical plate height we measured in the centimeter unit. So you need to convert the 2m long to centimeter unit. So we get 200 centimeters divided by the number of theoretical plates we got here, and then we got the answer for the height, which is 0.05, 0.014. Okay, so I hope you understand this well, and because it is very simple question. Okay, we'll look at the exercise 2. Look at on the exercise 2. The table given here is the result that we got from HPLC chromatogram. So we have the components, retention time, width of peak base given by W, and it is all in the minutes unit. So the first component is unretained. It has the retention time of 2.8 minutes, and X component, which is 4.4 with a width of 1.15, and and Y retention time with 26.7 and 1.71 width of peak base. So the first question asks you to calculate the resolution RS for component X and Y. So you need to use the formula resolution given by our last notes, which is R equal to 2 to TRB minus TR, which is retention time for A. So you need to minus B first with an A, not A minus B, okay? And divided by width of A plus width of B. So you will get the resolution K2 26.7 minus with 4.4, okay, divided by 1.15 plus 1.71. So you get 15.59 minutes, okay. So what is the unwritten value here? So the unwritten value is actually the dead time or void time, which is show a peak of 22.8 minutes. Okay, so if the question asks you what is the dead time of this on this table, okay, please mention the dead time so you can straightly mention that the value of the retention time for the dead time is 2.8 minutes. Okay. Alright, second one is to calculate the selectivity factor for component X and Y. So the formula for the selectivity factor is alpha equal to retention factor of B minus, not minus, divided by retention factor of A. So in this table, it didn't give any retention factor value, right? So what you need to do is you have to find the retention factor value for A and B. So you need to use this formula, which is Ka equal to Tr minus Tm divided by Tm, or Ts over Tm. If the Ts is given, in this case, the stationary time Ts is not given. So, but the dead time or Tm is given here. So you cannot use Ts over Tm. You must use Tr minus Tm over Tm. So you need to calculate for both A and B respectively. So for component X, Tr value here is 4.4 minus with the dead time, which is 2.8, divided by the dead time 2.8. So you got 0.75, okay. And the component Y, you got 8.54. Then we will substitute this value on the formula given here. So make sure you don't put it wrongly, because you need to put k ky over kx. So this one is wrong. Okay. So what is the correct one? You must state that ky here. Okay, ky over kx. Okay. Actually, I'm purposely do it wrong here, because I don't want you to repeat this mistake. Okay, because if you do it like this, so you will get the wrong answer. So the true answer is the formula is ky over kx. Okay, and we will substitute it ky, which is 8.54 divided by kx, which is 0.57, and you will get 14.898 minutes. All right. And the last question, based on the retention factor value of x and y into justify this separation. You want this question wants you to justify the separation based on the retention factor value that you got here, which is kx and ky. Okay, so you can conclude it based on our notes here. Okay, let me show you. All right, the retention factor, if the question asks you to justify the separation, you must use this explanation. Okay, if the separation factor, if the retention factor is in the range of 1 to 5, so it will be considered as ideal separation. If the separation occur much less than range 1 to 5, so we can see that the separation occurs so rapidly that the accurate determination of separation is difficult. Okay, while when the retention factor is larger, which is in the range of 20 to 30, the separation times become inordinately very long. Okay, we proceed. Um, Okay, so the answer for 3, for component X, the retention factor is 0.57 and the separation is so rapidly that accurate determination of separation is difficult because it is less than range 1.5. Okay, and for component Y, the separation is good even though it is not an ideal separation but considered good separation compared to component X. Okay, so that is the answer for question 3. So I hope all of you understand it, and I will give you an exercise first before we proceed with our assignment. Okay.